Hello guys, this is Maysie Calzone and you're watching Maysie's Algebra Initiative, and today we are going over Unit 6. And as you can tell, I wrote it 4 times. All this lesson involves is everything to do with exponents. Now let's get started. Okay, these are the main 5 properties of exponents. We will go over them in the next 5 slides, and I'm just here to list them off to you. It's the product of powers property, the quotient of powers property, the power of a power property, the power of a product property, and the power of a quotient property. So let's start with, well, those are our properties, but let's start with what is an exponent. We have our base, which is the variable or number down below. And we have our power, which is what is written above it, like so. And that's all it is. It's a number raised to a thing. For example, x squared represents x times x, 2 x's. X cubed is x times x times x. Okay, so product of powers property. When you multiply 2 exponents with the same base, you may combine them by adding their powers. The key here is the same base. Like I said, the key here is having the same base. Now, you see in the example, we have x to the nth power times x to the m power, and that equals x to the n plus m power. So when you're multiplying 2 things with the same base, you just add their exponents. And here's an example with numbers down here. X to the second times x to the third is equal to x to the 2 plus 3, which is x to the 5th. The quotient of powers property is when you're dividing 2 exponents with the same base, once again, key word, same base, you may, I wrote adding, it's subtracting their powers. So when you divide it, you subtract. When you multiply it, you add. So here we have x to the nth divided by x to the mth, which is equal to x to the n minus m. And here's an example with numbers. X to the 6th divided by x to the 2nd is equal to x to the 6th minus 2, which is equal to x to the 4th. The power of a power property is when you raise an exponent to another power, you multiply the 2 powers. So if I had x to the m and I raised it to the nth power, that would just equal to x to the m times n. And here's an example with numbers, x to the 2nd, and then I cubed that. It would be x to the 2 times 3, and that's x to the 6. Okay, power of a product property. This means you can separate 2 variables like so. When raising multiple terms to a power, you may separate out each term and individually raise them to the said power, and then you can multiply them together. So if I have x times y to the n, I can separate that into x to the n times y to the n. And here's an example with numbers. X cubed times y, all to the 2nd, would equal to x2 times 3. And this one doesn't have to have the same base, as you notice. X to the 2 times 3, because that was part of our power property here. So, and then y to the 2nd. So I get x to the 6th and y to the 2nd. Okay, we have now power of a quotient rule. This is the same as the power of a product rule. If you are dividing 2 numbers and you're raising it to a power, you may separate those 2 numbers, raise them individually to that power, then divide them. So here's an example down here. I have x divided by y to the 2nd, and that would just equal to x to the 2nd over y to the 2nd. Okay, so here's some practice problems. Using your knowledge of exponent properties, simplify each term. I'm going to pause the video, and when you're ready to continue, you should pause the video to solve it out when you're ready to see the answers. Unpause the video, so let's pause the video now. Okay, so here's the answers. On this first one, I was able to separate them and then individually raise them to a power. I mean on the first one. On the second one, this was the quotient one, so I subtracted the powers because they have the same base, and so I got z to the second. On the third one, this is a real numbers application, so I had 3 cubed to the second, so I multiplied 3 and 2, I got 3 to the sixth, which is 729. For the fourth one, I got x to the third, xy to the third. I separated them out and then individually raised them. And on number 5, I had 5 to the third times 5 to the second. I added the powers, and I got 5 to the fifth, which is equal to 3,125. Okay, now we're talking about rational exponents. These are your square roots and your cubed roots for the most part. And these are represented as fractions. So if I want to take a square root, I would take whatever number it was to the half, cube root to the third, and so on and so forth. So if I had the fifth root of a number, it would be that number to the 1/5, and so on and so forth, which is represented down here by this thing. The nth root of x is equal to x to the 1 over n. And a good way to remember is that you take the root and you make it an exponent by turning the root index, which is that number out in front, and if it has no number, it's 2, by making its inverse of the power. To make its inverse the power. Okay, this is a really quick thing just to remember. A monomial is a single term. So an example of the monomial is x squared or x squared y. Non-monomials is x squared plus 2 and 3x squared plus x plus 1. Those are not monomials because they're made up of monomials, but they're not monomials themselves. Monomals. Okay, so let's talk about exponential equations for a second. A linear equation grows it just grows linearly, and it's just a very nice slow growth. But an exponential equation a linear equation has constant growth from each step. It increases the same amount for each step. An exponential equation, it grows exponentially, which means that it grows bigger and bigger and bigger and bigger every single interval you take. So like it's growing faster here than it is down like here. It's just growing faster and faster, and it's just going to go shoot up. And this is one of the ones you'll use the most, y equals 2 to the x. It's a very popular exponential equation. Okay, in this practice, I want you to write each root as an exponent. Okay? Pause the video now to solve it out, and unpause the video for the answers. Okay, here's what I got. Here, we notice that there's no thing in front of it, so we know it's x squared, so it's going to be 1/2. Then I had the 3. I make it its inverse, 8 to the 1/3, which is also equal to 2, by the way. 64 to the 1/6, that's also equal to 2. 81 to the 1/4, which is equal to 3. I wrote in parentheses because you weren't supposed to solve it out. You're just supposed to simplify it or not simplify, rewrite it as an exponent. And then the last one follows our n rule. You take the inverse of whatever this is, so it's going to be 100 to the 1 over n. Thank you so much for watching. I hope you learned something new today. I am Maysie Calzone from Maysie's Algebra Initiative, signing off.